Hello guys, it's Sunday. Not doing new problems today because I've got this huge long list of backlog revisions. So yeah, I'll try to do many problems today. Maybe 4 or 5. Let's see. We'll see. Also, okay, the first problem is contains duplicate. Given an integer array nums, return true if any value appears at least twice in the array and return false very easy. Array hash map sorting. Wait, is that all? Well, I can use a hash map, or yeah, sorting or hash map, linear. Integer and integer. Map is new map. Okay, and for num in nums, if map dot contains key num, return true. Map dot put the key dot get or default num. Okay, or just return false. That's it. It should work. Yep, this is such an easy problem. Space complexity linear, time complexity linear. Okay, next problem. Number of islands. Number of islands. It's a great problem, and I think this is my second revision of this problem. Let's just need to check. Number of islands. I haven't made a video on this problem. What? Number of islands, lead code. Nope. I haven't made a video. I haven't made any video on this problem yet. I have a feeling that I did this problem. Okay. Given an M into an 2D binary grid, which represents a map of ones, land, and 0 water, return the. Oh yeah, I recorded the video, but I didn't post it. So this is my second revision of this problem. An island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically. You may assume all 4 edges of the grid are all surrounded by water. Okay, so this is my input grid, and this one represents a piece of land, and this collection of one, this group of one here, it represents an island, even this one, because they have to be connected either horizontally or vertically. So this whole first four items, first four ones in the first row, these two ones in second row, these two ones in third row, they all form, well, even this is also a part of this whole island, this one island, because this is connected to. Okay, we have to return the number of islands. In this example, this is the first island, this four ones, group of four ones, and you can see they are not connected to any other one horizontally or vertically. There is this one, this is my second island, and this is my third island. Okay, so this is depth first search. I think we can also do it with breadth first search, but I don't know how. Okay, let's first try it with depth first search, and then we will try the other search. Well, for depth first search, I need a helper function. It'll accept a grid, and what I have to do is so I'm just gonna iterate over each cell in my grid. So for int I, man, I write Kotlin and that's so concise. Grid length I plus plus j0, j is smaller than grid's column length, increment j. See, Java 21. Okay, if my cell is 1, it's a char. I wonder why they have to use char there. I mean, they could just use int. If it's 1, okay, then I'm sending this point. Wait, should I send, yeah, row and column, right? Row and column. I'm sending this row and column into my DFS function I and j, and I guess, and in this function will basically check its neighbors. So it will check this cell, the cell which I have found. It will check its neighbors. I don't need a visited in this problem, because uh, uh, this is a recursion function, so base condition. Now let me just write the main thing. For marking something as visited, I can just say uh, grid row and column, let's make it 0, and here I'm gonna keep a counter. Okay, and increment my counter. So every time DFS is called, after my control comes back here, count is incremented. And because we are doing this thing in DFS, it will only be called for answer number of times, because the first time we find a piece of land, we'll convert all the neighboring, related adjacent cells into 0. So that way, we never, by the time we get back here, all these ones will have turned into 0, and so we never really send them in these. We never really send these cells into DFS. That's the basic idea. And for the base condition, I'm gonna check. Well, this is it. This DFS grid R plus 1 C DFS grid R minus 1 C DFS grid C plus 1 DFS grid R C minus 1. And I'm gonna have to check if my R and C if it's not 1, well then return, or if R is a, let's define it here, if R is smaller than 0, or C or R is greater than grid's length, or C is smaller than 0, or C is greater than grids, basically if it's out of bound, then return. Okay. Here we are doing what we would have typically done if we had a visited array, right? It's here in this case we're simply just manipulating the input grid. So count, let's return dfs. Dfs, what did I do wrong? Dfs out of bound. What do you mean out of bound? I just check this condition. Is equal to or if is equal to, yeah. Okay, all right. What is the space and time complexity? It's a DFS. We are checking. Are we checking each cell? Well, we are iterating over each cell, but we are calling DFS on one only, on cells whose values is 1. In the worst case, my entire grid is made up of ones, so that means, well, DFS will run on all the cells. Still we are checking every cell exactly once, so it's m into n two times, right, because of the loop. So time complexity is m into n plus m into n, which is just 2n to n. Space complexity we are not using any extra space other than the space this DFS search would take in my recursion call stack, which is what, m into n. Yes, space and time complexity is same. Let's just quickly verify this. m into n. Okay, cool. Now let's see if we can do breadth first search here. So how would I approach the same thing with breadth first search? Maybe I'm gonna need a queue, of course. So I will store I'll store all the cells having one value. So all these cells will go into my queue, right? But how would I 1, 2, 3, 4, 5, 6, 7. So if there are, okay, I know there are 6 cells in my queue. Some of them might form they could be separated, they could be part of one island. Okay, so I'll check, for example, this cell. I'll check its right side. I'll check its left side. It's already in my queue. Or maybe we can just maybe this problem is better suited for breadth depth research. Let's look at the solutions. Has anyone done this using breadth first search? Oh, there is an answer. An island is formed when it becomes. Whenever we encounter whenever we encounter an unvisited land cell, it must belong to a new island. Unvisited. Exactly what we are doing here. All right. Correct. True. Yeah, we're just doing the same thing. Here, instead of changing the input, a visited array is used. Okay, cool. Maybe I'll explore that some other day. Or no, who cares? Okay, next problem. Group anagrams. Given an array of strings, group the anagrams together. And I did this, well, I did this problem in last Sunday video. Yeah, and it's also easy. Yeah, this is given in this. So we are given this list of strings. Anagram is a word or phrase formed by rearranging the letters of a different word or phrase using all the original letters. So we have to group them. Bat, nat, tan. Ate, eat, tea. So they are just different, like rearrangement of same words. And the way we can solve this is we can we need a hash map, and maybe last time I tried using ASCII, like converting this string to its ASCII form. For example, A is ASCII form. A in ASCII means 97. T some number, E some number, and then adding all that number and using that as a key, I can store that list. But I think, yeah, there might be there is a simpler way to do this without using ASCII values, but I don't remember how. Or list of string new hash map so what should I use as a key? For a string in strings, do I have some Java string methods? Directorate count Unicode values, returns the Unicode of the character at specified index. Compared to concat contains equal copy value of returns a string that represent the equals equal ignore case format get bytes. Convert a string into array of bytes. You don't need that. Hash code returns the hash code of a string. We can use that as an index. In turn, is empty is last index, length matches, region matches, replace all, split substring, character array. Java hash code. I don't need a hash code. No, hash code will not do. Hash code is always different. That one is always different. So maybe if I convert this string into an array, into a character array, sorry, into a character array, is str to character array, and then convert this character array to something can I get a numeric value of this ch? Return new list of strings. Result is new array list. Okay. Return this list thing. Let me just see my character array. Integer. Okay, so can I do something like this? Okay, character type cannot be, okay. So we are back to that thing again. For character in ch, int key, key plus equal to right, and map dot put key if map contains doesn't contain this key, then map dot put key new list, and then map dot put key map dot get this key and add this string into my list. Okay, and at the end I can just in string. No, this is not list of string. String dot list map dot values. I think this is the function for doing that. Yeah, let's see. Contains key. By the ill. What? What is this? There's no anagram in this list. Each word has its own array. So what am I doing here? Just let's see what our map looks like after doing the above things. What does my map look like? Apparently these two have same, these two got allocated same key. Oh, rest are fine. So why is there only problem with this one? It's interesting. How do you get assigned same key? Did I do something wrong? That's very weird. What is the ASCII value of D? Let's see. Let's ask lead. What is the sum of the ASCII values of our each character in a string? DUH. Yeah, you tell me. I asked you. Tell me what number do you get after adding your ASCII values? Just tell me. You're stupid. You know, Lead is a stupid AI. Yeah, Lead is a stupid AI. Anyway, okay, you want some 3 to 1. Okay, they have the same sum. They add up to the same number, so that's why. So okay, this is not a reliable solution. This is a bad solution. What else can I do? Can I just do this? Maybe? Any chance? Chance of doing this? Yeah, sure. Each one gets their their own array list. So this is not reliable. Can I at least get some hint from your sorted? Alright, yeah, sure, sorted. Arrays dot sort character. How can I convert it back to string? Can I just sort my string value itself? Right? Is this a method? Yeah. So S1. How can I convert an character array into a string in Java? I'm wondering, can't I just directly convert this string? Can't I just directly sort this string and then store it as a key? Come on. ChatGPT is way better than this. I'm so stupid. How can I be so stupid? Partially. How can I sort a string in Java? You first have to convert it to character array, sort it, then convert it back. Okay, so there is no string dot sort method or anything. Okay. What is the, let's analyze the complexity. This map, what is time complexity, space complexity, I'm making use of a map. In the worst case, when there are no anagrams in the string, map will store every single string from the list. So that is a linear. Space complexity is linear, and time complexity, space complexity is linear. Time complexity, iterating over the list, converting each string to a character array, sorting that array, so n into converting. I think this takes linear time, converting a string to character array into a character array, and sorting is log n. So log n, converting that back into string is also a linear operation, and this is all just constant time. And then to n, so one can go n log n, and there is this n, so it's what, n squared log n. Is that even a thing, n squared log n? Okay, let's verify. According to me, time complexity of a solution is n squared log n, and space complexity is linear. But your time is not. Okay, strings average. Okay, so yeah, sure, k. I should have used k instead. So this is, yeah, k. God. Because we are talking about the length of the string. N is the length of the list. I mean the array. So for each n into, if there are, let's say there are k characters in my string, so that takes k plus k, converting it into character array and then converting it back to string, so k plus k, and sorting takes log k. 1k can go away. I mean, I think even log n, even this, because linear, this thing has more significance than sort k log k. Okay, sorting takes k log k, not only log k. N into k log k. Does sorting in Java takes n log n, right? Which sorting algorithm does Java use? Dual pivot, quicksort. I don't know why I can't always assume that sorting was log n operation. Space complexity, storing space complexity is linear. I think he meant n plus k. Oh, every version. Every solution frequency based hashing into n. Okay, this is slight improvement from this one. We don't have to sort in this one. But God, I mean, how can you read this code? So it's so difficult to read. Okay. Moving on. Longest palindromic substring. This is definitely my second or third attempt to this problem. I'm just gonna check. What? YouTube. Longest palindromic substring. Okay, did this one 4 weeks ago. 4 weeks ago. I've just seen from here. 1 January. Okay. Today is 1 Feb, so almost a month ago. Given a string, return the longest palindromic substring. The difference the way this question is different from other palindromic substring problems is that we don't know the starting and ending. So what we are going to do is we're going to expand from the middle. For example, if this is my string, right? It five characters long. I'm gonna start looking from this middle character. Left and right pointer will go into separate directions, opposite directions. I mean, so left pointer B A, and if both of them are equal to each other, well, they will keep going as long as they are equal to each other. They will probably stop here. Yeah, B. So A, B, A, and then we can use those. We can use left and right index to get my substring, and we don't need we need the longest substring, which is palindromic. So I'm gonna have to set a max variable for length, or maybe max. Let's say max, and a string where maybe I don't need max. Answer. Okay. So I'm gonna create this method, private. Should it return? What should it return? Expand from middle. And this will accept maybe left pointer, maybe a right pointer, and of course the string the S. So while left while left is greater than -1 and sorry, I got this call. If well, as long as they are within the bounds, that would be better. As long as with left is greater than -1 and right is smaller than s dot length. Or if s dot character at left is equal to s dot character at right. If this is not equal, break. If that's not the case, plus plus, and at the end I will return, maybe it needs to return an integer. Well, I need to return the let me see. In this problem, we are actually required to return the substring, not just the length of it. So, well, I'm going to check each character. I'm gonna run a loop on this string, and it will start here. First character is B. B. For int is I smaller than s dot length and all this boilerplate. Odd, even. I need to call expand from middle 2 times because of the length of the string. It can be either odd or even, right? So s I and I plus 1, s I passing the same index, I and I plus 1, BA. So left is B, right is A. Are my indexes within the bound? Yes. Are they equal? No. B, A are not equal. So break. Okay. But then what do I return back? clearly this is not a substring. I mean, clearly this is not a return r my left, okay, left, right minus left. So 2 minus 1 is 1. Should I return 0, indicating okay, I didn't find any substring there. The answer is 0. In even case, both left and right are equal, like they are same values, so this condition will, like, loop will not break. Left minus minus, right plus plus, so now left becomes out of bound while right becomes 0 1. Right is 1, left is minus 1. Because left, let me see, left minus 1, left is minus 1, right is 1. So in order to cancel this effect, r minus r plus 1, so that let's just cancel. Okay, so I'm gonna take the max of these two. Probably let's split this. Math dot max odd or even, and I think I need to check now if this max is greater than my current max. If max is greater than then I can just update my string, right? Substring. So this is the way I'm thinking. Now the tricky part is figuring out how to return from here, what to return from, left and right. Three. Here it should return me 3. So if and at this point the value of left is 4, the value of right is 0, 1, 2, 3, 4. Value of right is 4, value of left is 0. So right minus left minus 1. ABA or BAB is also valid. So expanding from middle, expanding from A. My left pointer is here, my right pointer is here, my left pointer is here. Then my left pointer will become -1 and my right pointer will become 0, 1, 2, 3. So when my left pointer becomes -1 and my right pointer becomes 3, I still need a way to return 3. So 3 minus -1 and -1. What does this return? 3 plus mm, 3, right? Why am I having difficulty doing basic arithmetic? I need to my rusty brain. I don't know. So 3 minus there are two negative ones, so that is, and this returns 1. I don't want 1, I want 3. Mm, CBBB. I don't know. Let's see. System dot flex. Here we have 2 max lengths. So now we've been able to figure out, okay, there is a substring of length 3 somewhere in the string. The character we used for expanding from middle is definitely the part of that substring. So can I use this information to get the indexes? Maybe this is inclusive. You know, it would have been really convenient if I just knew my left and right bond. Oh, here's the left bound of your substring, or here's the right bound of your substring. Can I just 0, 1, 2. At this point my I is 2. And if the answer is 3, if this if whatever I got is really greater than my current max, then my I and my ith character is definitely part of the that substring. So that would mean 0, 1, 2, 3 and I got the answer as 3. Max 3, index is 3, got answer is 3. Then yeah, this is wrong. Why am I even starting from I? Can I make use of well, at this point my answer was 0. There is no answer, it's empty string at index. Then I started expanding from middle from this index, and as soon as it returned 1, right? So 1 is definitely greater than 0. Do I change the value of my answer then? What is the value of my answer? It should only be B. B A. Yeah, no A, because we got length of 1. There should only be 1. Yes, B. B is not the right answer, but it is the length is greater than my current length, so at this point we don't know. And then next index A. Let me just, yeah, so when we expanded from this A, we got 3 as an answer. Can I say BAB? Well, I already have a B, so can I just add this substring to my this substring? Does that even make sense? Because I've already computed something, and if I can just add this newly found thing to my previously computed string, but CV is not even the right output. CB, why does it keep returning C? B, if we expand from this point, it will check right, it will check left. No, they don't match. But for the odd case, check left and they match. So left is 0, right is 0, 1, 2, 3. 3 minus 0 plus 1. 3, 0, 1, 2, 3. Right? Minus 1, I mean. So 2. Okay. Now we know that length of my substring is 2. So this is not right. No. Only when we expand from B at first index, we get the longest substring. 0, 1. 0, 1, 2. 0, 1. 0, 1, 2, 3. 0, 1, 2, 3. 3. Well, at a glance, it would just seem like that we get the perfect bounds. 0, 1. 3, ABA. But that's not the case. It's not the case. ABA. For some reason, Why does this thing change twice here? Even though my max is same, it's 3. It shouldn't have changed. It shouldn't have entered. It shouldn't have run this code because max did not change. It remained same, and the condition is if max is greater than length. So now, do I need? So either my max length. Let's okay. Int max. Keep it to 0 for now, and let's make it current max. Current max is my max. That's the case. Max is equal to okay. I give up. Okay. I don't even know what this is. Start. So apparently I never made use of this. So there is no way I would have gotten it right. What is this start? Okay, of course it never says start of any substring. It's set at 0 initially and is only updated when I find a new max. This part is right. I minus I minus current length minus 1 divided by 2. Do you have nodes, some kind of nodes for this? Start end. Start is I length minus 1 divided by 2 and is length divided by 2. So is this the same idea that my I is also the part of the, well, if it found a new max, then my I is the part of the new max. I plus okay, let's observe these. This code is really much simpler, but it's, I think, n squared complexity plus also this loop. Next plus start. And start. 0. I minus current, I minus my current is divide by 1. 1 0, so the whole thing becomes 0. I is 0, so 0 is 0, sum is 0, start is 0. Second time, current max is 3. 3 minus 1 2, 2 divide it, this is 1, and I is 1, so 1 minus 1 is 0. Yeah, but how did we get here? Works fine, sure, but how did we get here? Okay, I will probably have to watch something on this. Exactly. This is a much simpler way, in my opinion. If I bring this loop, cut and left is I. By the way, this is even. The other one is odd, or doesn't matter. Left and right, I plus 1. No, where am I? Okay, and I can just say that my answer is so it is equal to s dot substring left and right. Left plus 1 and right minus 1, just like temporary. Yeah, let's create a temporary string. Temporary is s dot substring if temporary answer dot length if temporary value answer is equal to temporary. Okay, I'm gonna do the same thing here. All right, this answer is really simple. I mean, more simpler and better than this solution, than the one I was trying to do. Okay, even this is for even number, even length string. Same thing. Okay. Should I just try it, or I don't know, I don't feel like it. Okay, it works. I tried it. It works. Very good solution. Way better than mine. Way better than I mean, I could just have the helper function return the indexes of the the bounds left and right. But yeah. Okay. Next problem. Lowest common ancestor of a binary tree. Have I think I no. Lowest common ancestor. Lowest common ancestor. Common ancestor of binary tree. Okay, I have done this. Okay. I don't remember if I got it right or not. 18 December. Yeah, it's been a while. Given a binary tree, find the lowest common ancestor of two nodes in the tree. This is a binary tree, not binary search tree. In binary search tree, finding the common ancestor is so easy. In binary, I mean, it's also not that difficult in binary tree. I'm gonna do depth first search, and lowest common ancestor is defined between two nodes as lowest node T that has both P and Q as its descendants, children. grandchildren, descendants, yes. So the common ancestor of 5 and 1 is 3, yes. 5 and 4, this 4 and this 5. Well, it has to be, by the way, a node a node to be a descendant of itself. Node can be descendant of itself. So this is depth first search. I'm going to do depth first search, but with a slight twist. In depth first search, when we are finding, for example, diameter of the tree, what we would do is we would get to the end of the tree when we reach the null point. Null. Well, yeah, so when we reach the null, then we would return null. In this case, we don't need to check the entire tree. We don't need to keep checking the sub trees until we come across null. Uh, what we need to check is if my root is p, or if my root is equal to q, then return root right, and let's get the left, so let's check the left side. So ancestor, common ancestor, root dot left p and q, and similarly let's check the right side. Right, p and q. Okay, and obviously if when do we return null? P and q are always present in the tree, but what can happen is both p and q uh, being on either side of the tree, so both p and q can be present only on the left side or only on the right side, and in that case we will not find anything. Like if both of them are on the right side, we will not find anything on the left side, so we will eventually reach the leaf node and null after that. We need to handle that case. If root is null, return null. Now left has something, like left has some node, right has some node. If you're talking about first case, the p and q are right below the node, so if neither of them is null, Well, if left is not null and right is not null, then that means we have found what we are looking for. We can just return the root. Else return whichever is not null. If null right, else left. Yup. Space time complexity. It's DFS, so it's height of the visiting every node in the tree. So it's linear. Space complexity is also linear because of the search stack that DFS search would create in my memory. Time complexity and they are both are linear. Can I say space and time complexity are h? Do we use h for that? And is the number. Oh yeah, we can just h. Yeah, h is the height of the tree. Can I say that? Can I say its complexity is O of n do I need to use h to denote space complexity? I don't know. Just tell me what I want to know. Height of the tree. It's the same thing. H is the height of the tree. Height of the tree. Well, the longest path from root to from any leaf in the tree, right, is height of the tree longest path from root to a leaf. Height of the tree is the height of the longest path from the root to any leaf. It could be on the right or the left, whichever is deeper. Okay. Next step from root. Okay. Diameter is a bit different because diameter may or may not include the root. It is the longest path we can find in the tree. So it doesn't have to include root. Okay, this problem was easy also. And I guess that's it for today. didn't didn't have many didn't have that many difficult problems for today, and I think it's good. It just feels good when you get get them right. Yeah, thanks for watching this video. From tomorrow I will maybe I'll do new problems tomorrow. I don't know.